Hello, everyone. Thanks for joining the GeoPITS webinar. Before we dive into today's webinar, I would want to introduce GeoPITS and what we do. So, yeah, so we GeoPITS act as a DBA partner for companies, and now we are shifting ourselves into data and engineering also. So we help companies to monitor and improve the performance of databases. So we are Microsoft Silver partner and partnered with MongoDB Databricks on the data platform side as well and the data engineering side. So any form of database, be it on MS SQL, MySQL, Postgres, MongoDB. So we work it on cloud or on premises. We help with all services related aspects, so our engineers will be there 24/7 around the services. So yeah. So coming to today's webinar, we have our webinar for today is titled as Practical Data Engineering in 2026. So just to introduce about our speaker today, uh, the speaker is Asha Holla. She is a data engineer and a tech speaker with expertise in AI, data platforms, and modern data engineering tools. So she brings hands-on experience in building scalable AI-ready data workflows using technologies like Azure, Spark, and Python. So yeah, now over to you, Asha, and all the best for today's webinar.
Thank you, Vidya, and thank you everyone for joining, especially on a Saturday. And also, big thanks to GeoPITS for organizing this and making this happen. Just give me a minute while I try to share my screen.
Sure, yeah.
Right. So, like the lot of context was already given by Vidya from GeoPITS. So, my talk is going to be around data engineering practices, how it is currently evolving in today's day and age, and how we as data engineers can kind of do things on our parts. What are the new things that we can learn to stay ahead of the curve and 10x our productivity and also our efficiently manage our workflows. So, little bit about me before we start. My name is Asha Holla. I'm currently working as a data engineer turned AI engineer at Bloom Value. Bloom Value is a startup company. We work in the health tech space on the US healthcare insurance side. And in my free time, I also like to engage with the local tech communities as a speaker and a mentor, again in the same data and the AI space, talking about the up and coming technologies. Coming to data engineering, as of 2026, I hold the Fabric certificate and the Databricks data engineering certificate. And that's my social LinkedIn. If you want to connect with me, have any questions, I'm always open to talk or answer those. So this will be the agenda for the next 1 hour. So we will talk about how things are changing because of the advancement of AI and how we can sort of become AI-built data engineers. And I will introduce you to agentic data engineering. We'll talk about whether it's hype or how much of it is real and how we can become agentic data engineers. And then we will move on to talking about the importance of data modeling, especially when a lot of the data infrastructure that we are building is consumed not by the end users but by these agents and these AI models, right? And we will talk about the three foundations or the shifts, I would say, the tools and technologies that we have to learn in order to become agentic data engineers. So one of them is ontology, and another one is a technology called RAG, and we'll also cover MCP. And we will also talk about how evals, although right now they're currently being managed by the AI engineers, will eventually kind of move to being a data problem itself. And we'll try to draw parallels between what evaluation actually is in an AI system and how we as data engineers can kind of take that role as well in our day-to-day job. It is very similar to the data monitoring that we are already doing. And then I will also talk about the new data stack that we can currently sort of use and learn about in order to become more AI filled. And the last thing that I'm going to leave you with is the top three or the top four things that you can start off by doing in order to be more AI enabled at your work, personal, everywhere. All right. So moving on, I am currently kind of looking for another job, searching for jobs. And while I'm applying, there was one very common thing that I noticed. So the job description for data engineers mostly stays the same. The tools and technologies that are being asked are also very much similar to what data engineers used to do before and are currently still doing. So it goes along the lines of building pipelines, moving data from one place to another, and all the while doing these transformations, ensuring that the quality is not compromised, and also support the other team of data analysts or data scientists, and also aid them to better do their work, and also work with stakeholders to understand the kind of impact that you're doing. So if I turn some kind of a knob, what kind of impact is it going to have on the customers? What is it that I'm doing, and how is it really impacting the people who are using these systems, right? So this is generally what the JD still says, but uh, an underlying change that I have mostly noticed is AI has kind of quietly creeped into all our workflows, and more I see that even in interviews, people are asking how much of AI enabled are you? Are you using Cloud Code for your day-to-day work? Are you using ChatGPT to do your SQL queries and things like that? And the shift is really that while our previous data infrastructure was built for humans, the current data infrastructure that we are building will be provided as context for the AI agents or the AI engines to sort of reason over, derive the data, and then uh, give a more grounded answer. So your job also not only becomes building and maintaining the pipelines, but also understanding that this particular data infrastructure or the data model or the documentation or the pipelines that you have built is going to be used by agents. So ensuring that it is getting not just a lot of information, but the right kind of information is also going to be your job. And it will also eventually be our job to sort of build these systems and take care of these systems to ensure that they're helping us in our day-to-day work. We will explore a little bit more about what it means a little bit later in the session. And also, the last but the most important, we should also be working with different kinds of agents. So I kind of have a personal story around this, what the last point really means, right? So I kind of started off as a data analyst, and data analysis, as you know, is kind of a very back and forth with the user kind of a job. So usually what would happen is that we would build a dashboard. The business is obviously not constant, so the questions would keep evolving. And every time a new question came back to us, we would have a data analyst in place who would intercept that question from the user, and they would maybe write a SQL query, or they would write some kind of a DAX query, pull up a visual, and then give it back to the user, right? So we sort of cut down this whole process by putting agents in place. So instead of the user coming back to the data analyst, they would open up a chat interface and they would just start texting it, asking some queries or some visuals that they required to be pulled up. And this setup really consisted of two, three agents, where the first agent would just try to understand what the user is asking, and it would try to match it up against a knowledge base that we had built, which was essentially the most asked user questions and their relevant SQL queries. Once, if there was a match, then the query would be extracted and then it would be run. If there was no match, then it would move the work to the second agent, which would try to construct the query from scratch by talking to the data model that is underneath the data infrastructure that had been built upon, and then it would sort of execute that query, right? So this alone reduced like one of our resources being used just for this back and forth with the user to them doing something more important, right? And also it became their job to sort of manage these different agents that are currently doing their job. So that is how important it is that we work not just with other employees, we also understand what it takes to work with different agents that we have deployed in the cloud, how to sort of take care of them, ensure that the data that they are getting is fresh and validated all the time. So moving on, there is this term that I see floating around a lot, which is called agentic data engineering. So I was exploring what agentic data engineering really is, and how it is different from what it is that a lot of us are currently doing. So, like myself, for example, I thought being AI build meant just taking some SQL queries and then, instead of me writing it from scratch, I would just prompt an LLM, try to go onto ChatGPT browser and then type any kind of context and get a prompt out of it or get a query out of it and keep repeating the process until I get the correct query and then paste it and run it myself. Right. I would also sort of use Claude Code when I was working with maybe Python or PySpark in my VS Code, things like that. So this is a good start, I would say, but this is not what agentic data engineering really means. So agentic data engineering is when you yourself remove from the loop. So you're not in the loop anymore. The agent is writing the queries, it is running the queries, and it notices that if something is wrong, the loop kind of retries again. And this keeps on going on until you get the correct answer, very much like the example that I gave before, right? So if the agent outputted some kind of a wrong column or the wrong DAX query or the wrong SQL query, the loop would run over again, and then the agent would keep on doing this until it was happy with the answer. And if there was any errors, that would get flagged. So this is what it means to take a process and then make it agentic, and eventually doing this for tiny, tiny bits and pieces of our process. So for maybe validation, we could have an agentic loop in place where rather than us comparing the source and the end systems, we have some kind of an agent looking at it, right? So iterating, so making, uh, AI enabling these little processes that are already in our data engineering workflow is eventually what is going to lead to us being agentic data engineers. So moving forward, these are just some of my thoughts, and then thoughts of like few uh, influencers that I read online and that I mostly agree with. So first thing that we have to realize is that agentic data engineering definitely is blooming. It is not autocomplete, but that is what most of us are doing. But the earlier we realize how it is that we can learn these agentic frameworks and include it in our day-to-day workflow, that is where it is going to be our edge or our advantage, and that is how it is going to help our work as well, and then expedite the sort of influence or the work that you're doing. So that is the first thing. And the second thing that we have to, again, like I'm at the risk of repeating myself, I'm just going to say this again, where we have to understand that the current data systems that we are building are, yes, one thing, they are going to be used by the users, but more than that, it is going to be used by the agents. So it kind of falls to us that whatever we write is easily understandable to the agent. So there is plenty of documentation everywhere, and that context is again provided to these agents so that they know what it is that is currently happening, and they retrieve the right kind of context. So much like how in data systems, data quality is a very big issue. With AI systems, data quality is again a very big issue, but here it is more of the question of context, whether you have provided a lot of data, but is it the right data? Is it really required? So all of these questions will come into picture because AI needs a lot of metadata, but then it is also important that the right metadata gets retrieved, because context rot is a problem that is often seen with these LLM systems, where if you give these models a lot of data, although relevant, it might still sort of hallucinate and pick up the wrong kind of things because you're giving it a lot of information. And the last trend that I'm really seeing, and even I have sort of jumped onto this bandwagon, is while your data systems might be distributed, so you might be using some kind of an orchestration framework and your data might reside in some database, and maybe your documentation is in some other place. All of this can be quickly integrated with the help of the MCPs that are already given by these service providers. And you could just connect it to your agent so as to get this rich context that is residing across all of these distributed systems. And it would be really easy to manage and build these AI systems. So we will just, I will show you the code and I will show you how it is that I am currently working with this kind of a setup so that we understand what it means, and we can also include it, you can also include it later on in your workflows as well. And one more thing I really wanted to cover before we move forward is that I feel for the most part, the vendor lock-in issue is really kind of ending, mainly because tools like Databricks are really sort of putting out these open table formats, which essentially means that your data remains your data, but then the compute layer is provided by them. So the migration cost also, one more thing is earlier days, the migration when you're moving from one data platform to another, it would be a really big sort of a problem. So you'd have to consider a lot of things, how to sort of educate the users that are using it, how much time would it take for the developer to sort of learn a new system and then do the migration, what kind of issues would come up, how the backups were sort of managed. All of these things would have to be taken care of. But with help of these AI coding systems, we are able to do the migration very fast. So if you're not happy with the system, you can quickly move in and out of it depending on the kind of coding tools that you're using. So whether it is low code or no code, all of it will be very quickly enabled by these coding tools without really considering the downside of how much time it will take for the migration to happen and whether it has happened in the right space. So the space for us to experiment is really kind of expanded a lot, which I think is a very good thing. And the last thing is, of course, the platforms are sort of once they all have the same kind of offerings, they will be competing eventually on the price and the performance ratio as to who provides the best deal out of them all. So rather than you facing the vendor lock-in and then thinking about migration, you can sort of evaluate across the board and then see what works for you and for which situation. So that is one thing that I see is going to change. It is already changing across a lot of these major data platform tools. So I just took a brief case study of the three data platform systems that I have really worked with and just my thoughts about it. So if we start off with Databricks, the stress on open source is really sort of heavy because they push you towards Delta format tables, and the tables are getting stored as Parquets and so on and so forth. It is good for, again, large scale engineering. So the compute is provided by Databricks, but then your underlying data, you are bringing the data, which means wherever you have stored your data in whichever cloud platform is still safe. So you don't really have to worry about a lot of the HIPAA or the GDPR kind of laws. And one thing that I see with Databricks is that they have a really strong support for governance with Unity Catalog, which is again a really good thing. And then ML Flow for monitoring. Also, Genie Code is another good AI editor that they have built into the Databricks platform, which is a really good thing. Again, since we are talking about agentic data engineering, having this Genie Code or an AI platform, AI tool that is really sort of integrated into your website is something that will really help. But one thing that we have to be careful about with Databricks is that as your scale increases, the cost also is going to increase with that. So that is one thing that we have to look out for. Coming to Snowflake, again, Snowflake also has its own AI agent called Cortex, which I haven't used much, but I have heard good reviews throughout. And this one is more of a compute and a storage. Both of it is there on the Snowflake platform. So you can either connect to your own data platform, data storage location, or you can use Snowflake's offerings as well. So that is really up to you. Microsoft Fabric is another natural option if you're already in the Azure stack. So a lot of the orgs which are using Power BI, and maybe they have their data stack onto Azure, like ADF and like blob storage, it would make sense for them to move to Microsoft Fabric. And I think that is the idea that this particular organization also has. So they are gradually considering the shift from ADF to Fabric and so on. One good thing about Microsoft Fabric that I really like is that they are putting a lot of work into building these MCPs, because of which you're able to quickly connect to different tools that are really distributed, and you're able to extract the kind of information that you need. So be it your pipelines or some kind of notebooks and semantic layer and so on. However, the one thing that I don't like about Microsoft Fabric is that it is a bit costly, given that this platform is only 2, 3 years old. So it is still maturing a lot. Like the Git integration isn't all that good, and there are a lot of issues. A lot of items are still not generally available. They're in previews, so it is really hard to debug. And there are some issues, but again, if you're on the Azure stack, it would be the natural move to sort of move to Fabric. So that is one thing. And now let's talk about the stuff that really matters, right? So data model, and how does data modeling matter in the age of AI? So I feel with data modeling, the biggest shift is that our earlier data model was to make our data infrastructure easily understandable, make our dashboards readable for the users, but now it is going to be used by the agents. So the agents, with the help of MCP, will be able to directly tap into your data model, and they will be able to extract all the sort of column documentation that you would have written, or the table definitions that you have written. It will also be able to extract the measures, the kind of relationships that you would have built between the table. And with the help of it, it will be able to sort of use this to build its own uh, analysis at runtime or as and when required. So that is one thing. Um, so there is also a more evolved version of a data model called an ontology, which is, I feel it is again an abstraction on top of your existing data model itself, where if you have, say, n number of tables, right? So let me just show you the kind of dashboard I have an example of. So just so you understand. So there is this healthcare dashboard that I downloaded from the internet, and it has all these tables, right? So if I'm just to close this, you can see there is a physician table, fact table, and then there is a, uh death table, payer lookup, diagnosis codes, CPT codes, all these kind of things. So if I come back here, we first try to get out all the entities, so the members, and then the claims and the providers, and then we map out the different relationships. So which table accesses it when. So it is basically like defining your data model in a very simple way again, so that it will be used by the agent. And this can be again used by your RAG system, or it can be used to tap into your MCPs can tap into your ontology and give it to the agent. So we'll just see how that is possible. We already covered ontology, which is again an easier version or a more readable version of your semantic model. Uh, the other two things, or the other two pillars that I feel are really important when it comes to building AI ready data, or how rather data engineering is going to change, is these two technologies, right? One is RAG, which stands for retrieval augmented generation. Retrieval augmented generation right now is mainly being used by the AI engineers themselves. It is not really much of a data engineering task as of now, but I feel eventually it will kind of move into data territory, because what RAG is essentially trying to do is give the right kind of data to the LLM system. And how we do it, so I just have a piece of code. Let's have a quick look at that. Right. So as you can see here, I have a basic RAG pipeline, and the RAG pipeline is trying to get uh, it. So we have an LLM that is trying to answer some of our questions, and the questions that it is currently answering has to be based out of whatever is present in this particular file. So this is pulled out of some Claude Anthropic website where you can see all the Claude models, when they were released, what kind of capabilities do they have. All of that is mentioned, and how many tokens, what is the cost, what is the uh, versioning and the migration plan. All those things are mentioned, and it's mostly in a table format, right? And this is a .md file. So what I'm trying to do is having my LLM just retrieve the kind of information I need based on the kind of questions that I am giving. So this is again a data retrieval problem, ensuring that whatever data I'm using is new. That is one thing that I'm supposed to do. The other thing I should ensure is in a RAG pipeline, I should ensure that whatever chunks are being retrieved, they are right and they're correct. So let us have a look at this. So first I have my file here. And the first thing that we are going to do in a RAG pipeline uh, is take the file and then split it by the number of tokens. So the one thing that you are going to notice is that it already is broken down by sections. So we have Claude 1.x, Claude 3.x, Claude 3.7. So each of these tables, right? Either you could split it by maybe 200 characters, 300 characters. So if you did that, one thing it would ensure is that, the tables would kind of get broken into half. So maybe this is like my first chunk, this is my second chunk. So when I give this to the model, the information that I'm giving is kind of half and half. It is not full. So the first thing that you'll have to do is ensure that the chunking happens properly. So the cutting up of the document happens properly. So for that, what we are trying to do is extract the data section wise. So we are going to take uh, the first 8 lines as the first chunk, and then the next table as the next chunk, and then the third table as the third chunk, the tiny fourth table as the fourth chunk, and so on and so forth. So that when any question related to maybe say Claude Sonnet 4 and related to what is Claude Sonnet is asked, I get this entire context. It is not cut into half or cut into maybe 200 characters and like one of the columns is there, other one is not there. So such kind of a thing does not happen, right? So again, it is a data validation check which we are trying to do, which we have to do with chunking, which is very important to ensure that your model is giving the right answers. So coming back to the README file, we chunked it by section. Once you're done with the chunking in a RAG pipeline, what you're trying to do is you take the text that you have currently cut up and you map it in the vector space. So you convert the text to numbers, which will essentially be in the form of vectors. So this will be like multi-dimensional vectors. And in the vector space, all of these will get mapped. So now that we have our text representation in form of matrices or numbers, we are going to store that in a vector database. Again, this is similar to getting data from a different source and then ensuring that it is right and then storing it in a database, which is a process that we are all too familiar with. And the next thing that we have to do is retrieve the relevant chunks during runtime. So when a user asks a query, the process starts again where we try to convert the user's query into a set of matrices or numbers, and then we try to do a search. So we take the user's query set of numbers, and then we take the all the set of matrices that are currently in the vector space and see which has the least distance. So once we get the nearest chunks, we try to get like top 3 or top 4 based on the kind of distance. I think in this case, it is top 2 chunks. And then we pass it all to the model. So the model right now, instead of having to look and search through the entire data set that is there, I can quite possibly pass this whole file as well, but I am just passing the relevant chunks along with the question so that it already has the question and the answer. It just has to sort of decipher it in English and then sort of clean it up and give me the answer, right? So that will ensure that the context dot problem is not happening, where I'm just providing not a lot of data, but the right kind of data that the LLM really needs. So all of these steps that we just talked about, you can directly associate it with the data engineering process, where first you sort of take the data from some kind of a source, which is what we have done. And once you ingest the data, you are going to see how best you can store it. Before storing, you're also going to be enriching the data with different kinds of data sources. So the chunking here can be considered as an enriching step where you're trying to look at different chunking strategies to see which works best during retrieval. Once you have that ready, you store it in the database and then you retrieve it uh, correctly as and when required. And then, of course, once this entire process has run, to validate it, you'll also have to have an evaluation pipeline, which we'll talk about a little bit later. So if I'm just walking you through the code here, we can ignore all of the imports that I have done. So first we are going to do the loading and the chunking. So it will ingest the file and it will split at either these 2 hash or the 3 hash. So basically where it finds the tables, sorry, where it finds this kind of a section in the markdown file, it is going to split or create a chunk at that place. And once it does that, so all those chunks are going to get returned. So here you can see I've already printed it out. So we have total of 52 chunks from this entire .md file, which is of, I think, 200 or 350, 65 lines, right? So the first 4 chunks I've printed it out. So the chunk 0 is just going to be, I think it's an introduction sort of a thing that we already have here, the first 2 lines. The next chunk probably is going to be the table of contents. Yes, I was right. And then we have chunk 2, which is again the model release timeline, all of that is mentioned. Chunk 3 is again the next section, so on and so forth. So moving down, once we have validated that the kind of chunks that are retrieved are correct, I am just going to move on to my next step. So there is a cache involved and all of that, which we are not going to get into right now in the interest of time. We are going to convert it to indexes and then we are going to put it into our vector database. Once we have done that, it is just a retrieval step that is left. So let me just make you look at the system prompt that we are giving. So the agent is supposed to only retrieve what is there in my file. If it is not there, do not speculate. Just tell that I currently don't have that information, right? All of that is mentioned so that I don't get some hallucinated fake answer. So if I just go down, I ran it for 2 questions, right? When was Claude Sonnet 3.5 released and its key features and so on. So here, as you can see, it has retrieved the chunk and it is also kind of giving me the correct answer. Uh, but however, in this Claude file that I have, I for sure don't have anything related to OpenAI or GPT-4o. So what happens when I send this query? Will I get any chunks returned? So let's look at that. So in this case, no chunks are returned. So the response will be, I don't have enough information to answer that. So that is how this whole rack pipeline is going to work and how we as data engineers can kind of associate the steps in a rack pipeline similar to building a data pipeline, or think of it as data pipeline in the age of AI. So we are supposed to decide what data is relevant right now. If the data retrieved is correct, if it is not correct, fix that and ensure that we have some kind of telemetry setup so that we can validate and monitor this once it goes into production or for a larger scale. Coming to the last thing, MCP servers are one more thing that we have to be really sort of be understanding about and how to use that as well. So MCP servers are, think of it like when you're using packages like NumPy or Pandas, you aren't really writing the code underneath it. Rather, you're just using the sum function or the subtract function and so on. So MCP server is again something similar. So when you're connecting your LLM to an external system, you will have to write some kind of a custom API code. So if you're connecting your LLM to an inbox, you'll have to use the Gmail API, give it some kind of a password and all those things. But with the help of MCP servers, the API code gets managed by the Gmail folks itself. So you don't have to worry about what happens when the API gets updated. Will my code break or not? So it is like importing a library again, but for API. So that's the whole thing with MCP servers. So there are a lot of MCP servers that I use in my day-to-day workflow. So one of them being Power BI MCI. SQL Server also has an MCP server that we can use. And coming to Azure, I think Azure DevOps, Azure, the platform itself has an MCP server. So all of these will ensure that you can use the pre-written code that is already there with the API calls and then get the right data as and when required. So we already covered everything related to RAG. I'll just quickly run through this slide. So a RAG is essentially a retrieval pipeline, which we already went through. So you're going to own and maintain it as a data engineer. You have to ensure that the knowledge source is regularly getting updated, and you'll also have to do version control for that data, just like how we currently do it, right? With our normal data systems. So that has to be done. The refresh and the monitoring, all of this will be taken care of by the data engineers eventually. The chunking strategy, which we talked about, very important to get good answers from the LLM. So that is again something that the data engineers will have to look at. The kind of embedding, the model you use for embedding again matters a lot. In this case, I think it's the open source Hugging Face model that I have used. And then the vector store. So there are n number of open source vector databases. So you'll have to sort of think through which vector store to use and when, because each of them have their own sort of downsides and upsides, right? So all of these, which currently people feel is an AI problem, will eventually become data engineers' day-to-day work. And again, like we just saw, the quality really depends upon what kind of information you give to the model. So if you have done the chunking right, if you have done the indexing right, then your LLM will give you the right answer. If it is not done right, there is a high probability that the user might get some wrong kind of result. It might retrieve some chunks. Your system might retrieve some chunks with the wrong confidence scores and embed them in the answer, which is uh, again a validation problem, right? So that is one thing. Once you have your rack set up, it is good to have an evaluation pipeline also in place. So think of it like how we validate source data set to your destination data set, ensure the number of rows are correct, ensure the data types are not changed, no schema drift has happened, that kind of a thing. So for evaluations again, yeah. So evaluations right now are owned by ML and AI teams, but eventually it is going to be data engineers who will have to look after this. On a larger scale, we'll have to understand how to work with these tools like Open Telemetry, or I think Azure Application Insights for that matter, and then understand what really is happening in each of these LLM calls, what kind of chunks are being returned, how to sort of better it over time and monitor this effectively. So that will fall on to us. So the test sets also, the testing will be done by data engineers itself. Currently, it is on the AI side. Like we talked about, the evaluation pipeline has to be continuous. It is not one and done. Like just like how we run data validation checks every time the data pipeline runs, every time a RAG pipeline or an AI pipeline runs, the evaluation also has to run along with that. So if I come back, I just have the open telemetry tracing setup as well. So here, this is just an import of the open telemetry. Once I have that, I'll just move down here. So I have just given it some ground truth here so that we can test what happens when we run these queries. So here I've asked when was Claude Sonnet V2 released, and I have given it the answer as well. So Open Telemetry is going to evaluate if my answer actually has these phrases in it or not, and it's going to give some kind of a score. And then we can categorize each of the questions as well. So this question is going to come under version and release. The next question I have asked will come under pricing because I have asked about pricing. And the last question again, it's the invalid question, right, on GPT about OpenAI. So this will come under off topic. So we are going to see here, I have already run this piece of code. If I come down, you're going to see for the first two runs, the keyword hit rate was 0.67. But in the last one, the keyword hit rate was 1, which means all of the keywords that it was supposed to pick up, it has actually picked up, which means it had to say, I don't have enough information, and it has actually told us that. So in this case, it is the validation pipeline is 100% match to what we were expecting. So that is one way of how a very basic evaluation pipeline is done. So coming back, we covered RAG, we covered evaluation. The next thing we are going to talk about is the MCP servers. So MCP servers is, like we already talked about, it is the API code that is managed by the service provider themselves. And it also comes with definitions, rich definitions rather, which ensures that it can be used by the LLMs so that they know which tool to call and when. So I'll just show you how I have used Power BI semantic model. So the same way you can set up any kind of MCP here. I'm using the PBI Power BI MCP, and we are going to see how to set it up, what kind of users it can give us, and how it is really sort of making faster our work. So if I come back to this dashboard here, I have all of this tables. This is the semantic model. So first thing I'm going to do is, yeah, I will first open my Claude, and you will have to actually go to the official GitHub repo of these MCP servers. So that is one thing you'll have to check for. Uh, a lot of these MCP servers are built by non-official sources as well. So ensure that whatever you're using, either you have built the MCP or it is this one is from Microsoft itself. So it is safe while you're using it. And once you're using the MCP, as you can see here, you connect it to your chat interface. In my case, it is Claude, and it is talking to my Power BI desktop. So I already have this file open. So we'll see how it will help us understand that. So for installation, right, just come down here and you will find this JSON code. So just copy this JSON code and open your Claude. Once you're in Claude, just make sure to go to settings, and on the settings, go to the developer settings. So here you can see that I have set up the Power BI MCP server and it is currently running. So if I click on edit config, you will see that it points to Claude desktop config.json. So if I double click on this, you are you are going to notice that whatever code that I copied earlier from the repo, right? I have the code that you see right here. Sorry, the code that you see right here. So this is CMCP server. I have just switched it out to my this thing, and it is really put into Claude config.json. So save it and then close it. Right, come back to your Claude, just restart it. You'll be able to see Power BI MCP server. So now just go back to your chat. Right, so I am back in my chat. Let me just go fully up. So the first thing I did was just go here, go to connectors, click on Power BI MCP server, and then start using that. So I said connect to Power BI desktop. So it will ask me what is the file name and so on. So it also told that, yeah, I find that file. And then it connected to the Power BI desktop. So I asked it, so since this was a dashboard that I downloaded from some online GitHub repo, I have no clue what is happening here. So I just asked, what new insights can I give other than what is already here? So using this sort of MCP server, it was able to go and have a look at the data model and then look at all the measures. So it just gave me some of the things that are already there. So the time taken for me to understand this data as well has reduced. So if I go back, let's just validate if it has given us the right kind of, give me a minute. Right, so that total payment is already existing. So it was able to look at all the measures and then give me the insight. So I asked it, what are some things that I can already do that is not already in this dashboard? So it gave me like few ideas to explore the data. So it said specialty, CPT cost breakdown and stuff like that, patient age band, ethnicity region. So I just picked up one of those answers and I told, okay, give me a new page. So right now it does not have any way to build a page, but however, what it did was actually construct all of these columns and measures that were required. So it told me how to construct it as well, and it also built these measures. So if I go back and close this, I was just validating it some time back. It gave me this whole new set of measures, right? Total deficit, total payments, blah blah blah, which I can then sort of follow this guide and then build a page out of it. So even the code was able to be automatically written to be written for me. That was another thing that it did, right? And then I asked it, how can I read the dashboard? So it even helped me understand the data that is currently given. I did validate it across the actual data set and then what it is showing here. So it is pretty much right. And coming down, I asked, this is one thing that I really like. So in Power BI, right, documentation is another problem. So I have all these columns, but what do they actually mean? I have all these measures, but what is the meaning of these measures? There is no description. Rather, we should have someone sort of sit and write these description. Of course, you can create it with Copilot, but that is still a manual task. And we know that in production dashboards, rarely is there only so many uh, tables, right? So it will be like a lot of tables, lot of cross relationships, and really confusing for someone new to onboard. So what I did was I asked it, just pick up the CPT code lookup table and generate some kind of a documentation for it in the columns. And it was able to do that as well. So it has told me that this is the documentation it has generated. So if I go here and click on the first column, you can see that it has plugged it in by itself. So that is another thing that you can use. So this description later on, you can extract it and then give it to the, uh, your AI engine so that it understands the difference between maybe a column that says full name and a column that says first name and another column that says last name. So these kind of things that only the developer would be privy to, you can sort of quickly generate a lot of definitions with LLM, and then you'll be able to validate it and then give that to the LLM so that it understands what it is that it is doing while building these queries or validating things. So similarly, like how we set up Power BI MCP, you'll be able to set up the SQL MCP as well. Again, it has a lot of features that have to come out, but documentation, running queries, execute, create, all of those things are already available. So make sure that you explore that. So what we are trying to do here is uh, reducing the friction between accessing these data systems by doing it conversationally. So that is one way of putting it. Let me go back to full screen. And this is the last thing that I really have. Right now, if you talk about the tech stack for a data engineer, it's going to be integration from different sources that is really domain dependent. So if you're in healthcare, it could be some FHIR, EHR, and so on. If you're in banking, it is some other system. It could be even your unstructured, structured, whatever, right? And then you have your data platform, so your lakehouse, warehouse, whether you're going to use Fabric or Snowflake, you want to go to an open source DuckDB, Duck Lake, all those things. So that is your current data stack. How your data stack is going to evolve. So you will be responsible for the ontology semantic layer, which we partly are at this point in time. I feel the difference between a data analyst and a data engineer is fast fading these days. So that is one thing that we are already well and good with. RAG layer, which we just now talked about, providing the right context to the LLM, will be again one more added skill that will be very, very useful for a data engineer. MCP server, quickly being able to talk to these different systems with the help of LLMs and then speeding up the work, making all of them cross talk to each other is one thing that MCP server really provides. So that is another good skill set or a tool to add to your toolbox. Agent runtime is just being aware of how to build these very basic agents and run them, which I have not really gotten much into today. But you will be able to find a lot of these, what do you call it, the baseline code, uh, if you just look up the documentation. So that is that. Coming to evaluation pipelines, we already had a look at it, how we provide the ground truth and then how we do a testing for like a mini batch is what we did, but you can sort of scale it up as well. So this is how it was before and how it is going to evolve. And before we close off this session, I think we are almost at the top of the hour. I will leave you with this. So maybe on Monday when you come back, you can start exploring maybe one domain or one part of your work as how to sort of set up ontologies there. I know the data model is something that we are already familiar with, but how to translate it into an ontology is one thing that you can get start with. And then also trying to understand how to use Claude or GitHub Copilot with these MCP servers, enabling these MCP servers and using it maybe first in your local and then understanding how to deploy it, how to use it in cloud would be another added good thing that you'll be able to add to your toolkit. Build a very simple RAG pipeline. So this particular code, I'm going to put it on my GitHub. So if you want that, you can retrieve that, maybe make it better, try different kinds of strategies, do different kinds of chunking, do use different libraries, see which fits and what does not. So again, it's an experimentation thing, and each person will only understand it better if they do it themselves. And the last thing really is understanding how telemetry fits in. So open telemetry is one such framework which you can use. So either you can use the same code that I just did a brief demo of, or you can do more research about it, use some proprietary tools that are already available for tracing. I think Langsmith is another tracing pipeline for LLM. So those are the four things that I feel will be most useful for us, uh, which will give us the most ROI in the coming years for us as data engineers. And with that, I think we come to an end. I have just put a QR code here. So although our conversation might end here, I will take any questions right now if anybody has. If there are no questions, you can also connect with me on LinkedIn and you can personally DM me as well if you have any questions or uh, have any conversations that you want to do. So yeah, I think that is really about it.
Yeah, thank you, Asha, for providing a comprehensive overview on how practically data engineering works. So yeah, now we are at the end of the webinar. So as Asha told, if the team has any queries or questions, please go ahead. Feel free to ask. Yeah. Maybe the silent view take has there's no any questions. So if you have any, so as Asha gave her LinkedIn account, so you can contact her there. So yeah, we'll wind up for today's session. Thank you for joining and always keep looking out for new upcoming webinars in future as well. So we'll be posting the highlights and the resources of today's webinar on our YouTube channel and also follow us on LinkedIn. So you'll be updated on the new webinars that will be coming up in the future. So thank you everyone and have a great weekend. Thank you,
Awesome.
Asha.
Thank you so much. Thank you, everyone. Thank you to GeoPITS as well.